practice problems. So you can do that practice problems. So many questions we are putting in the slides, so and their solutions as well. So welcome you all in the course AOC ZC111 Probability and Statistics, and this is context session number 15. And in this one, we are doing the hypothesis testing. So if you remember that in the last class, we have done the hypothesis testing. There are two types of hypothesis. EC2 results are announced. Syllabus pending, it is this is context session number 15 and 16. One more chapter, that is the 11, chapter 11.1 only we were just doing. So in the next class, we will do it, or I will try to finish it today, if it's possible. Okay. So in the last class, we have done the hypothesis testing. So if we have the two type of hypothesis, that is the null hypothesis, and second is the alternate hypothesis. Okay. So H0 we can consider an equality claim, and that's why it is we are defining H0 is theta is equal to theta naught and the null value. So if you remember in the last class, we have done two hypotheses here, and the right tail, left tail, and the two tail. Okay, and in that one, this is like a left tail, and we have to identify which is the left tail and which is the right tail. So this was the example when we had done the right tail specifically. Okay, and this is the example which we have done the two tail problem. So firstly, we identify the H0 and HA, which is the, and then we can identify that they are left tail problem, right tail problem, or two tail problem. Got it? So that part we have already done. Then we are just mentioning the errors. So in that one, we are mentioning the errors, and in that error, we are doing the error, and error is what? With the probability of type 1 error and probability of type 2 error. So probability of type 1 error is what? We are the probability when we are rejecting H0, given that it is true. So there is some error. And similarly, probability of type 1 error, which is denoted by the beta, which is the probability of we fail to reject H0, given that H0 is false. Correct. So these two type of errors we have done in the last last class in section 7.5. Now we are starting section 7.6 according to your textbook. Okay. So we are just taking here, this is the right tail problem, this is the left tail problem, and this is the two tail problem. I already mentioned it. And then we can just say, okay, this is the left tail problem, and here the rejection reason in the left part of the curve, and this is the right tail curve or the rejection reason in the right side of the curve, and the two tail here when theta is not equal to theta naught, and the rejection reason in the both side, left side and the right side. So there are two tail where we can get the rejection reason. That's why this test is known as the two tail test. Okay, that part we have already done. This we are doing just in a brief. So what we do in the hypothesis testing, we set the appropriate null and alternate hypothesis, and then we determine appropriate statistical test. That is which test is appropriate. Identify the critical point of preset value of alpha. So alpha is provided to us, and based on that level of significance alpha, we are just find out what is the critical point. And then what is the critical point? In the one tail, it is Z alpha, and the two tail, it is Z alpha by 2 here. Got it? Then we can find out what is the critical region. So if it is a right tail, the right tail of the curve, left tail test, so that is the left tail of the curve, and two tails, so both tails we can just consider. Okay, what is the rejection reason? Then we are calculate the test statistic based on the given sample data. Okay, sample data, then we can use the test statistics, and then we compare that the test statistics fall in the critical reason or not. So if it is fall in the rejection reason, critical reason, then we can reject H naught, otherwise not. So that part we have already done 7.6. Any query till now? Please reply me back. No one is replying. Am I audible?
Yes, ma'am.
Okay, thank you. So now we are doing the section 7.7, that is hypothesis concerning one mean. Hypothesis concerning one mean means what? We are just talking about the mu. Okay. So as in the confidence interval, do you remember the confidence interval we have done for mu, and we have done the 4 cases. So same thing here we are doing that 4 cases when we are doing the hypothesis testing for mean. So here we are trying to identify what are the test statistics basically. So these test statistics are coming from the hypothesis testing as you have done in the interval estimation. Okay. So the same 4 cases we are discussing here as we have done in the interval estimation to find out the confidence interval for mu in a 4 cases. Okay, so same 4 cases we are discussing here. So same 4 cases means what? When the value of sample size is n. Okay, so now population distribution is not known. So if population distribution is normal, so n is less than 30. Okay, and population is not known, so we are just taking about n is greater than 30. Okay, so if n is greater than 30, so we can apply the central limit theorem. Correct? And what is the central limit theorem? Anyone, please? Tell me what is the central limit theorem? Any one of the student? No one is replying here. Okay. I don't know. Okay. Large enough sample size, correct here, that n is greater than 30. But after that, what we are saying, that distribution of the mean always be normal. We always be normally distributed. Okay. So X bar follows the normal distribution. So when we are applying that CLT, n is greater than 30 and sigma is known. So we are saying X bar follows the normal distribution. So X bar minus mu naught upon sigma upon root n follows the standard normal distribution. So this is our test statistic. Okay. But if sigma is not known, we are using the same thing because we can apply the central limit theorem. But at a time, we are saying n should be greater than 40 because sigma is not known. So instead of sigma, we are using S here. Okay. So x bar minus mu naught upon s upon under root n, that is our test statistic. We know the x bar, we know s, we know n, we can just substitute, and we know the mu naught also, which is the concept of the h naught. Okay. So we are using here this concept, and we can find out the value of the test statistic. Okay. Now, if population is normal, so if sigma is known, so it is again, we can say x bar follows the normal distribution. So we are using the same thing as we have done earlier. X bar minus mu naught upon sigma upon root n, that will become our test statistics. Correct. But if sigma is not known and population is normal and small sample size. Okay. So the three cases we are taking here, that we have already done in the confidence interval. If n is small, okay, and sigma is not known, okay, and that we can say here that population is normal. It is an important one. Okay, so we are using the t-text, and then we can say x bar follows the t distribution with n minus 1 degree of freedom. Okay, so at the time we can say x bar minus mu naught upon s upon under root n follows the, we can just say, the t distribution with n minus 1 here. So at the time we are using the t distribution, the t value, the z statistics is the t value, and we can compare the rejection reason by the t alpha by 2 n minus 1. Correct? So now we are doing again a special case, that all the three cases we are having the z distribution, and one case we are using the t distribution. So these are the five steps or of the algorithm to do the hypothesis testing. First is, what is your hypothesis testing? That is the null hypothesis and alternate hypothesis. Correct. Now we are saying it is not is greater than mu naught here. Firstly, we are doing this. It is greater than mu naught means what? It is a right tail problem. Okay. So now we just, next is what we are just calculating, because here large sample size, population distribution unknown, but sigma is known or unknown, whatever it is. And that is also available when small sample size, normal population and sigma known here. Okay, so in these three cases, we are just using the Z test here. This is known as the Z test. Okay, because here we are using the standard normal distribution. Correct. So it is a right tail here. Now we are using the Z test. Z test is x bar minus mu naught upon sigma upon root n. Now we are finding what is the rejection reason and acceptance reason based on the our alpha. Okay, and then we can calculate it is Z alpha, because it is a one tail. So we are saying it is a Z alpha because here it is the Z alpha value, and this reason is alpha here, the shaded reason. Correct. That is the correct. Our shaded reason is what? Our rejection reason, and unshaded area, white area, is the acceptance reason. Correct. So now we are just to find out the rejection reason at the significance level if Z is greater than Z alpha. So our test statistics is this Z. Okay, and if it is fall in the rejection reason, and it means Z is greater than Z alpha, so we are just using say that we reject H naught. Okay, so we reject H naught if Z is greater than Z alpha. Similarly, we can go for the left tail. So here left tail is what? Mu is less than mu naught. Okay, so we are calculating the Z value, capital Z here, and here rejection reason is the this left side here. Okay, and this value is what? Minus Z alpha here. Yes, we are using Z alpha by 2 when there is a two-tail problem. So if you remember in the confidence interval also, when we are using the two-sided confidence interval, so we are using minus Z alpha by 2 and Z alpha by 2. है ना? But if we are taking a one-sided confidence interval, so at the time we are using Z alpha. Same thing. It is a one tail, so Z alpha, and two tails, then Z alpha by 2. Because we are dividing the complete area alpha into the two parts, because it is a two-tail problem. Correct? So here it is minus Z alpha. So we calculate Z and then we can just compare if Z is less than minus Z alpha. So we reject H naught. Okay. Now in come to the two-tail problem. Two-tail when mu is not equal to mu naught here. And at the time we are calculating Z, and these are the two rejection reasons. So this is Z alpha by 2, and this is the area is alpha by 2 in the right side, and the left side, right side it is alpha by 2. So this value is Z alpha by 2. Okay. So our critical reason values are coming Z alpha by 2 and minus Z alpha by 2. So these are the two rejection reason we are finding. So we reject H naught if Z is less than minus Z alpha by 2 and Z is greater than Z alpha by 2. Okay. So if our test statistic fall in the rejection reason, then we are reject H naught. Otherwise, we have to accept H naught. So in the left, right, you can say in the right tail, that is the Z alpha. In the left tail, it is minus Z alpha. And in the two tail, minus Z alpha by 2 and Z alpha by 2. So these are the critical values. Okay. So these are the hypothesis testing we are doing in three cases. Now the fourth case, when sample size is small, normal distributed population and sigma unknown. So because sample size is small, then we can't apply the CLT. So we have to use the T distribution. Okay. So in the T distribution, we are using the degree of freedom also. So again, the same thing. We just say it is a right tail. Now we are calculating the statistic x bar minus mu naught upon s upon under root n, because sigma is not known, so we are using here s here, correct? And it follows the T distribution with n minus 1 degree of freedom here, correct? Now we are just saying right tailed here, so it is the critical point is what? T alpha. So this reason is the rejection reason, the right of the this point, okay? And then we reject H naught if T is greater than T alpha. The same thing, only the difference is we are calculating T and then we compare it T with the T alpha with n minus 1 degree of freedom. Okay. That is known as the critical point basically. Okay. Now we are just going for the left tail. So it is a left tail, mu is less than mu naught. Okay. Again, we calculate the T value, that is x bar minus mu naught upon s upon under root n. Okay. All information is known to us. Plug in the values and you can calculate it. After that, we know that it is a left tail. So this is the rejection reason. T alpha or minus of T alpha. So it is going in the left tail here. So the rejection critical point is minus T alpha. So we reject H naught when T is less than minus T alpha. Now we are just talking about the two tail. Then mu is not equal to mu naught. So it means here in the right side it is alpha by 2. In the left hand side it is alpha by 2. So the critical point is minus T alpha by 2 and plus T alpha by 2. Okay. So we reject H naught when T is less than minus T alpha by 2 and T is greater than T alpha by 2. Then T test statistic fall in the rejection reason and we reject H naught. Otherwise, we fail to reject H naught. Okay. So here, this is the left tail. So you can see this is the left tail here. And if we are talking about here alpha is 0.10, means what? 1 minus alpha is equal to 0.9. Okay, so the significance level is 0.10. So this area is 0.10 here. So we are finding Z 0.10 with minus sign. So that is coming minus 1.28. Okay, that is coming minus 1.28. So after that, we calculate the Z value here. Z is equal to x bar minus mu naught upon sigma upon 10. And then we can just check that this Z lie in the critical region or not. If it is lie, then we reject H naught. Otherwise, we fail to reject H naught. Okay. What type of error we are doing if we reject H naught? It is type 1 error. If we are fail to reject H naught, such a time we are committing type 2 error. Similarly, we can go for the right tail. Mu is greater than mu naught. Mr. Randir, T distribution always come with degree of freedom. So you can check in the table. I showed you the table value also. Somewhere it is a degree of freedom is given and critical values are provided in the T table. So always we are using the T alpha by 2 with n minus 1 degree of freedom. Otherwise, you are not able to identify which T value we have to take. Okay, so we are taking n minus 1 degree of freedom. Now this is the case of the two tail here. So this region will become alpha by 2. This region is become alpha by 2 here. Okay, so this is the two tail case here. And if we are talking about alpha is equal to 0.05, so this will become alpha by 2 is equal to 0.025. This value, this point, critical point is minus Z 0.025 and this is plus Z 0.025 here. Correct. In the right tail problem, 1 minus alpha is 0.95. Now the significance testing. So we are doing the hypothesis testing and then significance testing. Significance testing that we are trying to find out the p-value. So in so many softwares, if you are working on it, so you can find out that Excel will provide you the p-value. And when we are doing anything in the any calculation in the based on sample on in the Excel also, they also provide the p-value in the table in the results. So what is that p-value? That is related to the significance testing basically. Okay, so the p-value is the probability calculated assuming that null hypothesis is true. Which type of numeric is asked? It is given in the question that you do the hypothesis testing or you can you just calculate the p-values. Question should be very much very much clear that what you have to find out. Okay, so it is in the given question that do the hypothesis testing. So you have to do the previous method, and if it is mentioned that calculate the p-value and find out the answer conclusion based on p-value, then you have to calculate the p-value. Example we will do later on, just wait. Okay. So in this one, alpha is what? Our conditional probability. But here this p-value is not a conditional probability, so that is not a same value for probability value, it is a different probability. So it is a probability that we are assuming that null hypothesis is true, obtaining a value of the test statistic. So important is the probability of the test statistic at least as contradictory to H naught. In hypothesis, the some theory point is given as we have done in the last class now. Some examples, so that not clearly mentioned in the question. Theory thing is given, so you have to identify that which tail you have to use in that particular type of question. Okay. So as the value calculated from the available sample. So we are just find out the probability of test statistic when we are just assuming that null hypothesis is true. Okay. And this test statistics value we have already calculated by using the sample data. So some key points in that one, that p value is a probability, definitely. This probability is This probability is calculated assuming that the null hypothesis is true. So we are just taking mu is equal to mu naught here. Beware that p-value is not the probability that H naught is true, nor it is an error probability. Okay, it is not a type 1 error or type 2 error, and not is the probability that H naught is true. We are just saying we are assuming that H naught is true and the probability of the hypothesis testing. Okay, or you can say the probability of the test statistic. To determine the p-value, we must first decide which value of the test statistic are at least as contradictory to H naught. So we are calculating the test statistic and then we can put it is a contradictory to H naught. Okay. So the value obtained from our sample, that is the value of X bar, value of the complete test statistic. How to do this value? The algorithm for doing it, as in the hypothesis testing, develop the null and alternate hypothesis. Then we compute the test statistic based on the sample data. And then we are using the test statistic value to compute the p-value. So how we, and if we reject H naught, if calculated p-value is sufficiently small. Okay. So if p-value is sufficiently small, then we reject H naught. Otherwise, we fail to reject H naught. Okay, so here we are not having the critical point, critical reason. We are using by the p-value. We can calculate that this is H naught is rejected or not. Okay, so in that two-tailed problem, how to find out the p-value? So 2 multiplied by probability of Z is greater than ZC. Okay, mu is greater than mu naught. That is what? That is the right tail. So Z is greater than ZC. It is the probability. And now we are just taking about the left tail. So in the left tail, mu is less than mu naught. The probability when Z is less than ZC here. Okay, so that is the p-value basically. So this Z is coming from the test statistic, and this is the random variable, and this Z is coming from the Z statistic. Okay. So what we are doing, if in its upper tail Z test, so 1 minus 5Z, lower tail, that is left tail, so it is 5Z, and if it is the two tail problem, so we are taking 2 times of 1 minus 5Z. Okay, it means what? 2 times of this, and probability when Z is equal to mod of Z is greater than ZC here. This is the way to calculate the p-value. Okay, that we have done, that it is the right tail. So p-value upper tail, it is 1 minus phi z. Lower tail, then it is a phi z, because probability when z is less than zc. So this is the zc. So this probability we are trying to find out. Here alpha is not given basically. Okay. Now p-value when sum of the area in the two tail. So this area and this area, and we are just summation it. And this is what? Minus z alpha by 2, and this is plus z alpha by 2. Again, we don't know the alpha, then we have to do like this one. So more generally, smaller the p-value, more evidence that there is any sample data against the null hypothesis and for alternative hypothesis. So H0 should be rejected in favor of HA. Okay, when p-value is sufficiently small. Now the question arises that how much value we can consider as a sufficiently small. Okay, it's very difficult to say small, sufficiently small. So we just want a one threshold basically. Okay, so for threshold, what we will do? We are just taking the p-value based on alpha. So we are combining the hypothesis testing and significance testing, combining. Hypothesis testing when we are having the preset value alpha, and then we are calculating this value. But in p-value, we don't know the alpha value and we are calculating the probability. Okay. So we are just combining these two, and all other information are the same as we have done. So in that case, what we will do? We just compare with the alpha, the p-value. If p-value is so, we are just saying if rejected H0, if p-value is less than equal to alpha. Now it's showing, slides are coming. Okay. Do not reject H0 when p-value is greater than alpha here. So we combine both hypothesis testing and significance testing here. Okay. So finally, what we are doing, we develop the null and alternate hypothesis. We have the alpha value. Then we are just collect the sample data and compute the test statistic. Then based on this test statistic, we are just calculating the p-value. Okay, compute the p-value. And then we can just compare p-value with alpha. If p-value is less than alpha, we reject H0. Otherwise, we fail to reject H0. Okay. If we reject H0, what type of error we are doing? We are committing type 1 error. If we fail to reject H0, what type of error we are doing? We are doing the type 2 error. Okay. Same algorithm we are applying. In all the three cases. Okay. Now we are doing a one question. I am just leaving on you. I'm just coming to after drinking the water. Just give me a 1 minute only. We just go through it. Mr. Sanjay, this context session 10 slides are already uploaded. You can just check. It is maybe with the CH9 and CH11. It is uploaded in the combined form. Please check. Okay. Just give me 1 minute. I will also check. Hmm. Alpha is given here. Are the slides visible? Okay, fine. Yes, I am explaining the complete question. Just give me 1 second. There is some problem came in my tab. I'm just trying to sort out that problem. Just give me 1 second only. Yes. So question is what? From long experience Coca-Cola company, it is known that the same question we have done. Do you remember? In the last class, the same question we have done. Anyone? Anna? In the last class, we have done. So in this one, the yield is normally distributed. So population is normal with mean 500 units. Okay. So what is given? Population is normal. Mean mu naught is equal to 500 with sigma is equal to 96. Correct. So now we have the first case. So first case means as a statistic, we are using the Z test basically. Correct. And then now it is sampling for a modified process. Mean yield is 435. So sample distribution that X bar is equal to 435 for a sample of size 50. So N is equal to 50. 1% level of significance. So alpha is equal to 0.01. 1% level of significance. Correct? So here alpha is 0.01. So does the modified process decrease the yield? So our new claim is decrease the yield. So that's why we are making here HA's mu is less than 500. So initially it was 500. Now it by the modified process it is decreased. We have to just making a new claim. Okay. So the opposite of this we can write as greater than also. So H naught will become here mu is greater than equal to 500. Correct. And it is a left tailed problem. Why it is left tailed? You are saying because if we are just going back, we are saying here mu HA. HA's mu is less than mu naught. So that's why it is left tailed. So it means we are making the graph and this is the left tail here. The rejection reason is this. And this is what? Z alpha. And this reason is what? Alpha. The area of this region is alpha here. Correct? Mu is less than 500, not greater than. You are on which slide? Which slide is visible to you? From a long experience? Just give me 1 second. So why you are saying mu is greater than 500? Mu is less than 500. If it is less than, no, it is less than 500. Formulate the Z calculation. So we have already mentioned that it follows the mu is not 435. It is X bar which is 435 based on a sample. Okay. So mu is not 435, mu is 500 and by using the new process, it may decrease or may not decrease. So we are just checking is it decreased or not. Okay. So that's why it is decreased means mu is less than 500. Left tail problem. Now we have already identified that we can apply the Z test here. So we are using X bar minus mu as sigma upon under root n. So this is minus 4.79. It is given decreased. Because of this decreased term that, okay, initially it was 500, correct? So mu naught is 500. But they have made some changes. Yes. Okay. So this is a Z test. Now step 3, because it's a 1% level of significance. So we are taking the Z alpha with minus sign. So minus Z of 0.01, that is minus 2.33. I believe that every student can calculate this Z alpha minus 2.33. We have done so many times in the interval estimation also. Okay. So it is minus 2.33. So now we compare minus 4.79 with minus 2.33. So this value is minus 2.33 and our Z test will lie in this region specifically and a rejection reason. So what is the conclusion? Since Z calculated value minus 4.79 is less than minus 2.33, so we reject the null hypothesis because the Z statistic is lie in the rejection reason. Okay. We reject H naught means what? We accept H1, HA. Okay. And our HA is what? That it is decreased. So we are just saying here that by using the modified process, the yield is the mean yield. The mean of the yield is decreased. We are accepting this. Okay? Yes. Correct, Mr. Randir. These are the 5 steps only. So it's a very simple actually. ठीक है ना? Now we are doing the same question with p value. Same question. Okay. So in this one, first step is same. Second step is also same. Same question. So it is a left tail. We are not making a changes. That you can see here. The question is same. Only the same question we are doing by the p value. Okay. So here you can just mention here the question. Do it by p value. Okay. So we are just using this. Now p value. P value we are finding that probability when z is less than z calculated. Z calculated is minus 4.79. So we are saying probability when z is less than minus 4.79. Now by the standard table, standard normal table, this is approximately 0. Approximately 0 means what? It is very, very small. If it is very, very small, we reject H naught. Okay. And that we can also compare p value alpha. So alpha is what? Alpha is equal to 0.01 and 0 approximately 0 is less than 0.01. So we can say we reject the null hypothesis. So that is the combination of hypothesis testing and significance testing. Okay, by the p value here. Another example. Same example we have done to define the null and alternate hypothesis. Okay. So a department store manager department store manager determines a new billing system will be cost effective. In the last class, we have done some part of this question. Do you remember? So the mean monthly account is more than 170. So new billing system, they are claiming that because of the new billing system, mean is increasing. That is coming more than 170. Correct? So here our HA is what? The new billing system, new is greater than 170 here. That is the new claim. Okay. So H naught will become here, mu is less than equal to 170. Correct? So mu naught will become here 170 here. Now what is given? A random sample of 400. So N is equal to 400. Sample size is large. Sample size is large, then we can go for the Z test only every time. Monthly account is drawn for which the sample mean is 178. So X bar is also given 178. It is known that the counts are approximately normal distribution. So population is normal. So just read the question very well. Yes, correct. It's a right tail. Correct. And with standard deviation 65. So sigma is also given 65. At 5% level of significance. So alpha is given 0.05. So what you will do? Yes, correct. Okay, so what we will do? What is given, we just write it, and what is asked. So can we conclude that the new system will be cost effective? By using the hypothesis testing. So we are finding the hypothesis first. So it is a right tail. Correct? Next part is what? Find out the Z statistic. Okay. So x bar minus mu naught upon sigma upon root n, it is coming 2.46. The next part is what? We have to find out the Z alpha. Z alpha, Z 0.05 is 1.645. Got it? Now, what is the conclusion? Z calculated is greater than Z alpha. No, this is we are doing by the hypothesis testing only. Same question we are doing by two methods, two different methods. Okay. So, then only we require the Z test, Z alpha. So, Z calculated value is greater than Z alpha. It means that test statistic lie in the rejection reason. So, reject the null hypothesis. That is, we accept the HA or H1. Got it? Same question we can do by the p-value. So, what we have to find out the p-value? Z is greater than 2.46. This is 2.46. In the last so many classes we have done how to calculate this Z of 0.05. In the last question also I asked how we can calculate Z of 0.01. We can find out by the definition Z is greater than Z alpha is equal to alpha. So we have to calculate Z of 0.05. So it means what? Probability of Z is greater than Z of 0.05 is equal to 0.05. Now this is not a CDF. We convert it. CDF Z is less than Z 0.05. It is equal to 1 minus 0.05. That is equal to 0.95. In the standard normal table, where it is 0.95, accordingly we can find out the Z value. Okay, Mr. Vishnu? So now we are just doing here probability of Z is greater than 2.46 because this is a right tail. So that is 1 minus probability when Z is less than 2.46. Okay. So by the table, it is coming here 0.0069. So we can say here 0.0069, it is very small value. It is a small value. We reject H naught. One thing. Second thing is we can compare with the alpha. Alpha is what? 0.05. And we can compare with the alpha. P value is less than alpha. So we are rejecting the null hypothesis. Got it? Any query? Any doubt? It is given in the question. Don't worry, Mr. Randhir. See the previous year question paper, which is already uploaded on the eLearn portal. Please check. Okay. It is clearly mentioned that you have to calculate the p-value and then conclude. Step 3. Step 3 is the p-value. So it is a right tail. So probability of Z is greater than Z statistics. Z statistics you have already calculated 2.46. Not getting this Z means what? Z is a standard normal table, random variable, है ना? And that we compare. Then we compare with the 2.46. CDF of the standard normal distributed probability of Z is less than 2.46. Z is what? Do you forget? This is a standard normal table. You can calculate this one, the standard normal table. This is a simple CDF. 1 minus of this normal distribution we have done so many times. Okay. Next is the Third question. So just go through this, the third question again. Two-tailed problem. And you can just do it for the p-value also. I am just taking a break. Okay, just go through this slide. After that break, I will explain it. Please do it your own. Yes. After the break. Am I audible? Okay, fine. So your question is, what is the Z 0.025? Z alpha by 2, Mr. Mahindra. It is a two-tail problem. You got it? So when it is a two-tail problem, then we are comparing it by Z alpha by 2, not Z alpha. So you are calculating Z of 0.025, not Z of 0.05 as we have done earlier. That's why we are doing third question. Now some change. Example of the two-tail problem. Okay. So a drug is given to 10 patients. So now we can just write it what is given to us. So n is equal to 10. And increments in their blood pressure was recorded. So these are the data points of 10 patients. Correct. That is the changes. Increments or decrement or changes, because minus sign is also there, so it means decrement also. Okay. Is it reasonable to believe that drug has no effect on change to the mean? So we are just talking about mu naught is equal to 0. The mean there is no change, but if it is changed, then mu naught is not equal to 0. So we are just taking no effect on change, so HA will become here mu naught that mu, mu is not equal to mu naught. And then H naught will become here mu is equal to mu naught. Correct? So this is the two-tail problem. Now, what is given here? 5% significance level. So alpha is given 0.05. Assuming that population is normal. So population is normal. And variance is 1. So sigma square is equal to 1. Correct? Data points are given, you can calculate the X bar. X bar is coming 0.4. Data points are given, you can calculate it's 0.4. Correct? Now population is normal, sigma is known. So we are just going, n is small. So we are using the simple our Z test. Third case. Okay. So now we are using the Z statistic. Z calculated is the same. And this value is 1.265. Now, because it is a two-tail, then we can calculate the Z alpha by 2. So it is Z 0.025 and this is 1.96. Okay. So we are comparing 1.265 with the 1.96. So it is not fall in the rejection region, because if we just draw the graph, so it is like this one. So it is minus 1.96. This is plus 1.96 and 1.265 somewhere here. Okay. It is not in the rejection region. So we fail to reject H now. Okay. So we can believe that there is no effect on change the blood pressure mu. That mu is equal to 0, no change. Enough? Got it? Same question. We are doing the p-value. So if we are just going back, p-value, what we will do in the p-value? So to find out the p-value, we are just using 2 times of multiplication of probability when Z is less than modulus of this. So modulus is the same value because it is a positive. So 1.265. Okay, which is the same as is equal to 2 multiplied by probability when Z is less than 1.265. You can find out from the standard normal table and you can find out the answer. Okay, 1.265. And after that we are finding. Okay, it should be greater than. Sorry. Okay. So we are just saying 2 times of 1 minus 0.8962. Now, can you tell me what is the, why we are getting 1.8962? I believe that everyone can understand this point. So it is equal to the 2 multiplied by 1 minus probability when Z is less than 1.265. Okay. So it will become 0.2076. Now we just compare with the, it is very large value basically. So we fail to reject H naught. And we can also compare with the alpha. Alpha is given as 0.05. So this value, the P value is greater than 0.05, the alpha value. So we fail to reject H naught. So fail to reject the null hypothesis here. Okay. So we can believe that the drug has no effect on change on the mean blood pressure. Fail to reject H naught means we are accepting H naught. And we are not accepting that mu is not equal to 0. Got it? Any query? Now another question. The mean weekly sales of magazine was 146 units. Okay. So it is given as mu naught is equal to 146 units. After an advertisement campaign, mean of weekly sales in 22 stores. So N is equal to 22 stores for a typical week increased to 154. Increased. Matlab, if we are just applying the advertisement campaign, so definitely the weekly sales should increase. Or we are checking that it is effective or not actually. Okay. So it is greater than 146. So HA will what? Mu is greater than 146 and H naught is what? Mu is less than equal to 146. Correct? It is what? Right-tailed. Correct? Okay. Now what is given here? 154. So X bar will become 154. And a standard deviation is 15 units. Now, correct. It is a right tail. Now, it is given for the sample standard deviation. It is not given population standard deviation because it is given, it is for the 22 stores. So S is given as 15 units. So sample size is small. Okay. S is given, sigma is not given. Correct. So which distribution you can apply? Which test we are applying? Sample size is small and sigma is not known. I'm waiting for your reply. That is very important actually. This is the only one point. No, we can't apply CLT. That's the thing actually I am just discussing with you. Correct, Mr. Randir. T distribution. We are applying the normal distribution of CLT when N is greater than 30. Here N is equal to 22. Okay? That is the important part in the exam point of view also, because you have to identify that which distribution can be applied. All things are same. All procedures are same. But the important thing that you have to identify that which distribution, which test statistics we are using here. Correct? So here alpha is equal to given. Alpha is given as 0.05. And here we are using the T distribution. And for T distribution, what are the assumptions we required? One more assumption is required, that population is normal. So we start the question with let, because it is not given. So we just assume that let population is normal. If it is given, that it is okay. If it is not given, then we check, we write let population is normal, and then we start the t distribution. So it is given, and actually it is given that the weekly sales of magazine follows the normal distribution. Correct? If it is not normal, population is not normal, we can't apply the t distribution. So that is very important assumption we have to take to apply the t distribution. After that, all things are same, which you have already done. Mu is greater than 146, right tail problem. T calculated value x bar minus mu naught. Instead of sigma, we are using S, and it is 2.501. Okay? Now, at 5% level of significance, table it is provided or not? No, table nahi hai. Oh, table is not in the. Can you check this value? I don't have the t value, actually t table in the my tab. That's why I can't share you. Please check. You have the textbook, you have the Google also. From the Google, you can download the t table, and from the textbook also you can check that value. Okay, na? So here T alpha with n minus 1 degree of freedom. N minus 1 is what? N is equal to 22. So n minus 1 is 21. So 21 degree of freedom we are checking, and T at 0.05 we are finding. This value is 1.721. So what we are saying? T calculated value is less than our T alpha value. So we reject the null hypothesis. Correct na? It is 1.721. है ना? You can verify this answer. In the interval estimation, I kept this t table, but here in this one, I think I forgot. Actually, sir, I kept actually, but maybe it not saved. The latest version of the slides was not saved. I don't know. It was missed. Okay. So you can see in the textbook also, and you can just verify that it is 1.721. So you can say we are rejecting hypothesis H0. Got it? Any query? Now how we can do with the p-value? So in the p-value, probability p-value is equal to p of t. Instead of z, we are taking t, because here we are using t distribution with n minus 1 degree of freedom. Okay? Which is, because it is right there, so it is greater than. And our calculated value is 2.501. And with the degree of freedom, we are just checking here. Okay, here we know. Okay? Now by the t table, we can find out this value. So we can say t is greater than t value. It is this. Okay? Now in the t table, it is not a continuous form. Some points are given. So we just check here that 2.501, this value, we can get in this between. Okay. So 2.501, I am not able to get from the table. It's not possible. It is not given in the table actually. So what are the values at 21 degree of freedom? It's 2.080 and 2.518. And at what level? 0.025 and 0.01. Okay. If our this value, instead of 2.501, if it is 2.080, so this value is coming 0.025. If this value 2.501 value is increasing to 2.518, so the p value will become 0.01. So our p value is lie between 0.025 and 0.01, and we are not able to get the exact value of p value, because it is not provided in the table. Got it? Be careful about it. Okay. So now from that we can say it is p value is less than 0.025. ठीक है ना? And it is less than 0.05 and we are comparing with 0.05. So definitely p value is less than alpha. So we reject the null hypothesis. Okay. So there is some little bit difference between the z-test and the t-test. So you have to identify where we are applying the t-test, where we are applying the z-test. Okay. In the t-test, the table values are given for specific values only. And a table. So that's why we are not able to find out the exact value of p. So what we will do, we are finding in which region the p value lie, and then accordingly we identify that p value is lie in the rejection region which is less than alpha, so we reject the H0. Got it? Any query? Mr. Mahinder, Mr. Sanjeev, Mr. Randhir, Mr. Vishnu, Mr. Venkata. Mr. Akshay. है ना? I am talking about these students because these are the active students, I can say. I am getting the feedback from these students. Right now they are discussing with me. Okay, that's why I'm asking to these students. Otherwise, I'm talking about, otherwise I'm asking to all other students also. If any other student having any doubt, they can discuss with me. Correct? So little bit difference between the Z-test and T-test. Be careful about it. So we conclude that advertisement was successful at 5% level of significance because we reject the null hypothesis. Okay? One more question. The article described an investigation into the coating weight for large pipe resulting from a galvanized coating process. Production standard calls a true average weight of 200. So what is given here? Mu naught. Mu naught is 200 lb per pipe. The accompanying descriptive summary and box plot from the Minitab is provided here. Okay. So a normal probability plot of the data was quite straight. So it means population is normal. Okay. N is equal to 30. So data is given from the Minitab actually. And S is provided here 6.35. Okay. Now as descriptive output to test the appropriate hypothesis. Okay. So we are just taking 5% level of significance. So alpha is 0.05. Now we are just making the, correct. Alpha is 0.05. Now we are just taking here mean X bar is 206.73. Now we have to make the hypothesis testing here. Okay. So mu is not equal to 200 here. That is become 2 tail. Again, N is exactly 30. Correct. Sigma is not known. Population is normal. Exact 30. We are saying N is greater than 30. Then we are applying CLT. Okay. So we can't apply the CLT here. And we are using the T distribution. Okay, two tail here. So T value is 5.80, and now we are calculating 95% confidence level. That is alpha is 0.05. So we are finding the value at T alpha by 2 with N minus 1 degree of freedom. So N minus 1 is 29 and T alpha by 2 is 0.025. Correct? So that is 2.045. What is the conclusion? T calculated is more than T alpha by 2 with n minus 1 degree of freedom. So that will lie, the test statistic lie in the rejection region. So we reject H naught. ठीक है? Any doubt, any query? Simple, all things are simple. All steps are very simple. Now the next is section 7.9. So 7.8 is not in your syllabus. 7.8 is not in the syllabus, correct? 7.8 is not in syllabus. So 7.7 we are doing. Now we are just moving to 7.9. Calculating beta. What is beta? Do you remember? Calculating beta is what? It's a probability of type 2 error. What is the meaning of type 2 error? It is we fail to reject H naught when it is false. Okay. If it is false, so some value of HA is provided to us to calculate the beta here. Again, we have the 4 cases, but in this case, we are not using the T distribution. Okay. So we are not using the T distribution. Here we are using only the 3 distribution. At first is normal population with known sigma. So we are using the Z test. Right tail we are talking about. Okay. Right tail means what? Rejection reason is what? Z calculated is greater than Z alpha. Okay. Z calculated is what? X bar minus mu naught upon sigma upon under root n, which is greater than Z alpha. So from that, what we are finding that X bar is greater than mu naught plus Z alpha sigma upon root n. Okay. That is our rejection reason. So we fail to reject H naught when X bar is less than equal to this point. है ना? So H naught will not be rejected if X bar is less than equal to this. So we fail to reject H naught. That is the probability of type 2 error. We have done a one question also, if you remember. It is probability of fail to reject H naught. Given that is a conditional probability, then H naught is false. ठीक है ना? Now we fail to reject H naught means what? Probability we fail to reject H naught means X bar is less than equal to mu naught plus Z alpha into sigma upon root n. Given that mu naught is false, so mu is equal to some other value which is not mu dash. Mu naught. Okay, it is not mu naught. Mu dash, some other value. Correct? So mu dash is given here, denote a particular value of mu which exceeds the null hypothesis. Why we are saying exceed? Any one of you can say why we are saying exceed? Because it is a right tail value. Okay? Now we just find out again. X bar follows the normal distribution. So we can say this is probability when X bar minus mu dash upon sigma upon root n is less than equal to, है ना? Mu naught minus mu dash plus, oh sorry, this is not mu 1, it is mu dash. It is mu dash plus Z alpha sigma upon root n and whole divided by Z alpha sigma upon root n. Oh, sorry. So that will become here probability. This will become Z, standard normal distributed test, less than equal to mu naught minus mu dash upon sigma upon root n plus Z alpha. Okay. So it is become Z alpha plus mu naught minus mu dash upon sigma upon root n. You can calculate all the values and find out the CDF of a standard normal distributed random variable. And that will provide you the final answer of the probability of type 2 error when mu is equal to mu dash. Okay. Similarly, we can do for the same thing that we are finding in the left tail when HA is equal to mu is less than mu naught. That is the left tail. So we are finding the probability when x bar is greater than, है ना, यहाँ पे less than था तो यहाँ पे greater than हो जाएगा, and in the same thing mu naught plus z alpha sigma upon root n. So by using the same concept, z is greater than mu naught minus mu dash upon sigma upon root n plus zl. ठीक है? So that's why we are getting the another formula. So if HA mu is greater than mu naught, that is the right tail, and we are finding this. Phi, you know very well, is the CDF of the standard normal distribution. We have already used it. And then if it is a left tail, so it will become like this one. Okay. And if it is mu is not equal to mu dash, so it is in the two tail. So left tail point and the right tail point. Sorry, this is the left tail point and this is the right tail point. And here, what is the difference? Z alpha by 2. Z alpha by 2 and minus Z alpha by 2. So these are the formula. Okay, which is also provided in the textbook. And the slides are already allowed in the open book examination. So you can just take this printout of the slides. In the slides, be careful. You are just taking these slides only because here it is marked by the our institute. Okay? Any query? Any doubt? So section 7.9 is what? Calculating beta, that is the probability of type 2 error. In all the three cases. Three cases means all the three hypotheses. Left tail, right tail, and two tail. Okay. Now, if we are just checking the beta is provided to us. So what should be the sample size? Okay. We are fixing the alpha, we are fixing the beta. Now what we can move? We can move only the sample size. So how large the sample size we are taking so that we are getting this probability of type errors, different type 1 error and type 2 error should be minimum. Okay. So for that, we are using the same concept. This is the formula. Okay. Derivation of the formula I am not doing here because it is a lengthy. So I am not doing here. Direct formula you can apply to calculate the N here. Now we are just taking one example here. H naught is mu is greater than equal to 30,000. Mu is greater than 30,000. So it is what? Right tail problem. Okay? Right tail problem means what? We are getting this answer. Probability of type 2 error. So N is equal to 16. Normally distributed. Sigma is 1500. Okay? So we are using this formula here. So here in this formula, alpha is 0.01. So 2.33 is the Z alpha value. Z alpha value we required now. Z alpha we are required. So that is 2.33. Substitute in this formula, you will get the answer here. So mu dash is equal to 3100. We are putting here mu dash, mu naught is 30,000 minus mu dash upon sigma upon root n plus Z alpha. And that is become here minus 0.34. Oh, sorry. And it is 0.3669. ठीक है? That is the simple formula based question. Nothing else. But you have to identify what is given and what is we have to calculate. Okay? And beta is very large actually. This is okay. Now we are not saying that, okay, this, if you're just going back, it is 0.3669, which is large. So what we will just, we fix, no, we are not going for this error. We are saying instead of 0.3669, we are just replacing is 0.1. Sorry, 0.1, not 0.3, it is 0.1. Okay. So what should be the sample size? So Z alpha, so we can find out the Z beta also. You can calculate Z beta also. So Z beta is 1.28. Z alpha we have already calculated. So we are substituting the formula of N. N is what? 29.32. So the answer is coming here that it is 29.32, and that will become here N is equal to 30 tires. More than this. This is some, I don't know why it is coming. Okay. Any query? Just formula based. Okay, now come to the chapter 11. Should I do today? So I just give, okay, I will do in the next class. ठीक है ना? I will do in the next class, the last class, and this is the last chapter. I can understand. Because the hypothesis testing is a formula based now. So that's why it is a concept. You have to just, there is no need to remember actually, you have to understand the concepts actually. Okay. Okay, fine. So in the next class, we will do this chapter 11, and this is the last chapter. And only one section we will do in the test books, 11.1, not more than that. Okay. A simple linear regression. So in the next class, course for the EC3, complete course. But more emphasis is, you can see so many solved examples I am providing in the slides also. And these are the from the different from the test book also. Revision class, I will try to do it. Because in the last class, that is the context session 16. As I already told you that we have the limited class and we have the very large course content. So it is according to the your handout, it is fixed. Mostly part will come after the EC2. EC2 means what? The joint distribution, statistics, point estimation, interval estimation, hypothesis testing, and regression. ठीक है? Chapter 7, chapter 11. Mr. Rohit, 18th May is the last lecture. Correct, you are correct here, but I have already taken the previous questions, lectures now. So contact session 16 are over. So I don't know they will allow me to take the lecture class or not. Because my contact session 16 are completed, will complete in the next class. Okay, if they will allow, I will discuss with the authority. If they will allow me, then I will take the contact session number 17. Because what happened, actually, है ना? So that is the concept.